A shock wave is a type of propagating disturbance. When a wave moves faster than the local speed of a sound in a fluid, it is a shock wave. Like an ordinary wave, a shock wave carries energy and can propagate through a medium. However, it is characterized by an abrupt, nearly discontinuous change in pressure, temperature, and density of the medium. When a shock wave passes through matter, energy is preserved but entropy increases. This change in matter's properties manifests itself as a decrease in the energy which can be extracted as work, and as a drag force on supersonic object. Shock waves are strongly irreversible processes. Detached shock wave. Consider the supersonic flow over a blunt nosed body as shown in the figure. A strong curved bow shock wave is created in front of this body, with the shock detached from the nose by distance at a point A. The upstream flow is normal to the wave, hence, point A corresponds to a normal shock wave. Away from the center line, the shock wave becomes curved and weaker, eventually evolving into a Mach wave at large distance from the body. Oblique shock waves. An oblique shock wave, unlike a normal shock, is inclined with respect to the incident upstream flow direction. It will occur when a supersonic flow encounters a corner that effectively turns the flow into itself and compresses. The upstream streamlines are uniformly deflected after the shock wave. The most common way to produce an oblique shock wave is to place a wedge into supersonic, compressible flow. Similar to a normal shock wave, the oblique shock wave consists of a very thin region across which nearly discontinuous changes in the thermodynamic properties of a gas occur. While the upstream and downstream flow directions are unchanged across a normal shock, they are different for flow across an oblique shock wave. Oblique shock wave applications. Early supersonic aircraft jet engines intake were designed using compression from a single normal shock, but this approach caps the maximum achievable Mach number to roughly 1.6 Concorde, which first flew in 1969, used variable geometry wedged shape intake to achieve a maximum speed of Mach 2.2. A similar design was used on the F-14 Tomcat. The F-14D was first delivered in 1994 and achieved a maximum speed of Mach 2.34. Oblique waves are created by the same physical mechanism in which disturbances which propagate by molecular collision at the speed of sound, some of which eventually coalesce into shocks and others of which spread out in the form of expansion wave. To more clearly see this process for an oblique wave, consider a moving point source of sound disturbance in gas. For lack of better term, let us call this source a beeper. The beeper is continuously emitting sound waves as it moves through the stationary gas. Consider the first case when the beeper is moving at a velocity v, which is less than the speed of sound as shown in the figure. When the beeper is at point A, it emits a sound disturbance which propagates in all directions at the speed of sound, often an interval of time t. This sound wave is represented by the circle of radius AT in the figure. However, during this same time interval, the beeper has moved a distance Vt, the point B. Moreover, during its transit from A to B, the beeper emitted several sound curves, which at time t are represented by the small circles. In this case, beeper always stays inside the family of circular sound waves and that the waves continuously move ahead of the beeper. This is because the beeper is traveling at a subsonic speed. Now consider the case when the beeper is moving at a supersonic speed. Again, when the beeper is at point A, it emits a sound wave. After an interval of time t, this wave is the circle with radius. During the same interval of time, the beeper has moved a distance to point B. The beeper has emitted several other sound waves, which at time t are represented by the smaller circle in the figure. However, in contrast to the subsonic case, the beeper is now constantly outside the family of circular sound wave, that is, it is moving ahead of the wave fronts because V is greater than A. Moreover, something new is happening. These waves fronts from a disturbance envelope given by the straight line BC, which is tangent to the family of the circle. This line of disturbance is defined as Mach wave. Shock tube. The shock tube is an instrument used to replicate and direct blast waves at a sensor or a model in order to simulate actual explosion and their effects, usually on a smaller scale. Shock tubes can also be used to study aerodynamic flow under a wide range of temperature and pressure that are difficult to obtain in other type of testing facilities. Shock polar. Graphical explanation go a long way towards the understanding of supersonic flow with shock waves. One such graphical representation of oblique shock property is given by the shock polar described as: consider an oblique shock with given upstream velocity and deflection angle as sketched in the figure. Also consider an xy Cartesian coordinates system with x-axis in the direction v1. Figure is called the physical plane defined vx1, vy1, vx2 and vy2 as the x and y components of velocity ahead of and behind the shock respectively. Now, plot these velocities on a graph which uses vx and vy as x-axis. As shown in the figure, the graph of velocity component is called the hodograph plane. The deflection angle is carried through all possible values for which there is an oblique shock solution. Then the locus of all possible velocities behind the shock is given in the following diagram. This locus is called as the shock polar.